We're back with level-to-level projectiles, and we're going to be looking at symmetrical solutions to how to solve some of the information we need from a level-to-level projectile. Now, to do that, we need to understand what kinds of information we could be asked for. And here's a list. Calculations of interest would be time to maximum height, the maximum height itself, and time of flight. And we'd also like to know how far it goes over horizontally, or the range. So those are the things we might be interested in calculating. So let's proceed with the symmetry. First of all, we recognize that this is basically a symmetrical thing. As it goes up to the very maximum point, it's going to repeat that behavior, but going down on the other side. So what we're going to do is we're going to look at the fact that this has an initial vertical velocity, and that initial vertical velocity at the very top maximum height point, the maximum height time, that vertical velocity is 0. So we're going to use that with the equation for velocity and acceleration, and we're going to solve for how much time it takes to do so. And basically it's really simple. We set the velocity at the top to be 0. We have our initial velocity in the y direction, and so we basically do some algebra to find out that time is just the initial velocity divided by g. Now remember, this g already had the negative taken care of the equation, so you just put in either 9.8 or 10. Don't put in a negative, because then you'll get a negative time, and well, that just seems weird. Now, once we know that time to maximum height, we can actually then plug that into the equation y equals y naught plus v naught y times t 1/2 g t squared. Anyway, plug it into that equation for time, and we can find the maximum height at which the object obtains through the path of the projectile's flight or trajectory. All right. Now, we're not done there, because it turns out because it's symmetrical, if we know how long it takes to get to the top, we also know how long it takes to get to the bottom, so all we really have to do is double it to find the time of flight, or in other words, the hang time. And so that's kind of an interesting thing that, well, there's no x part in this equation to find the hang time. That's important to note that the time of flight of the object is dependent upon the vertical component of velocity, not on the horizontal. Now, speaking of the horizontal, if we'd like to find the maximum range which the object achieves, we just take the time of flight, multiply it to the velocity in the x direction, and that never changes because it's in free fall, so there's no x forces or x accelerations. And so we wind up finding out that the range is 2 times the initial velocity times the velocity in the y direction. So you just multiply the two components of velocity and divide by g. That will be how far the object travels. Now, there is a special situation that can occur. You'll be looking for time, but it will seem as though you don't have enough information. But it turns out you do. Now, in this case, you don't have range and you don't have time. You do, however, have the initial velocity and the angle. Now, because you have the initial velocity and the angle, you can actually calculate the components. And so we can find the component of the velocity in the y and in the x direction. Now, with that information, you can then look at the equation. But looking at this equation, we don't have enough to solve in the horizontal direction, and in the vertical direction, time is in 2 locations. But because it's level to level, we can actually do something special, because it turns out that our positions is going to be in 2 directions. So no need to scream. Now, we start off with the equation, and we substitute the component of velocity using v naught sine theta. Then we basically substitute in our zeros. Now here's the deal. When doing algebraic solutions, you can substitute zeros because it makes your algebra easier. You really should avoid putting in other numbers until you're done with the equation. But I know you like to put numbers in. Be careful. Also, there's an angle here, so as a reminder, make sure you check to see that you're in degrees or radians. Whatever you were provided in the problem, you need to make sure your calculator's on when you're calculating this. Now, the next step, of course, is to recognize that those 2 positions would be 0 because it's level to level. It's going to start at the ground and it's going to end at the ground. So that basically means those are 0. Now, with that being said, that being 0, we can actually move this term to the other side, and we wind up getting 1/2 gt squared and v naught sine theta times t. Now, there's a t in both locations on the equation, so we can basically divide by t and get rid of one of the t's on the left side and all the t's on the right side. And then we could basically just multiply by 2 and divide by g, and there is the time of flight. That's how much time it took the object to reach the ground. By the way, no big surprise here, but that's the same equation for time of flight that we had before. 2 times the vertical velocity component divided by g. If you knew that, then you really wouldn't have to worry about all the algebra. Just saying. All right, so that's kind of how you do some calculations using symmetry. What we'll be looking at next is going to be how to use your calculator to do some of the same stuff and the benefits that it actually holds for more difficult problems.